Today we're going to be beginning our final topic under the heading of populations. We're going to be discussing human populations. So we will be discussing human population growth and human population distribution and those sorts of things. But before we do, there is one last issue we need to finish up, which is related to our past discussion of endangered species. So I want to start out by discussing invasive species. The reason I relate invasive species to endangered species is because species that are invasive into communities can often result in other species populations declining and in some instances even becoming endangered. Now, generally speaking, invasive species are species that are alien to an ecosystem. They come from somewhere else, so they may not have any natural predators or competitors, and so they can build up to big numbers. They also tend to be R-selected species, species that produce many young, or in the case of plants, many seeds. And a lot of these R-selected plant species are things that can rapidly colonize disturbed areas. The Queen Anne's lace that you see in this photograph here is an example of an invasive species. It's a Eurasian plant. It's actually the ancestor of the wild carrot. And in North America, it can invade disturbed areas, but it can even invade established communities. Now, other species like this one here, the common reed, the Eurasian strain of this species is very much an invasive species, and it can invade established wetland communities. And in this case, it can replace the native cattail. And although the common reed is used as habitat by a number of different wildlife species, in many ways it still is inferior to the native cattail in terms of the kinds of quality of habitat it produces. So it fundamentally alters the nature of these wetland ecosystems that it invades. One of the species that the reed can displace is this one here, the golden club in the genus Orontium, unusual kind of thing. It's a relative of jack-in-the-pulpit. It grows in the same kinds of brackish marshes that are also very attractive to common reed. And so populations of this plant in the Northeast have declined as reed has invaded its habitat. So let's now turn our attention to human populations. And we'll begin this discussion by talking about population dynamics. The term dynamic means that something is not constant, it changes over time. And so we'll be talking about how it is that human populations change over time. For most of the past 2 million years, human populations have been rather small, under 500,000. And during most of that time, human population growth rates have been very small as well. It's only really since the 1700s that human populations have taken off, but since that time they have exhibited exponential growth, which is a phenomenon that we've discussed earlier. So from the 1700s until the 20th century, till about the 1960s in fact, human populations did increase for all intents and purposes in an exponential manner. Since that time, however, population growth has begun to slow. So now the graph of human population is beginning to exhibit characteristics of a logistic curve. And indeed, the change from exponential to logistic is just beginning, but we are starting to see the slope of that curve decline At its maximum in the 1960s, the doubling time for human populations reached its minimum of 35 years. Presently, human population doubling time is about 60 years, which is still a phenomenal rate, however, when one considers that we are already at 7 billion plus humans on the planet. There is a phenomenon called population momentum which relates to this. This refers to the tendency of populations to continue to grow as a consequence of their age structure, even after the time when fertility rate declines to just replacement level. Here is that graph of human population growth over time, and you can see that there is this long period when populations really didn't change much. But then about in the 1700s, the rate of growth started increasing dramatically as medical science improved and sanitation improved and technology permitted improvements in agriculture, all of which resulted in human populations growing much more rapidly. Human populations reached 1 billion at the beginning of the 19th century, and it was not until the early years of the 20th century that it doubled in size to 2 billion, a doubling time of about 119 years. However, by 1974, we doubled again, a doubling time of 51 years. And by the year 2010, we just about reached 7 billion, a doubling time of 36 years. Although, as I said, doubling time has now dropped to about 60 years. And in the years to come, it is predicted that doubling time will further slow. If we look at where human populations are distributed about the planet, it looks about like this, with especially Asia and India being the areas of highest density of human populations, with Europe also containing high population densities. The US actually has relatively low population density throughout much of it. There are also some pockets of higher density in sub-Saharan Africa and in Central and South America, but by far the largest area supporting dense populations is in Southeast Asia and India. Here's a close-up view of United States populations. These maps, by the way, are courtesy of U.S. Department of Agriculture and the U.S. Census Bureau. Notice that population density is highest in the Northeast, and there's a pocket in South Florida and some pockets on the West Coast around Los Angeles and San Francisco. Except for the coasts, however, much of the population of the U.S. is east of the Mississippi River. The western portions, the Rocky Mountain and Plains regions of the U.S. are rather lightly populated. Here are some summarizing facts about human populations. As we've seen, greatest densities are in Southeast Asia and India, and growth rates are also quite high in this region, as well as in parts of sub-Saharan Africa and also in the Pacific Island region, that part of the planet referred to as Oceania. If we look at total fertility rates, which is measured as mean births per female, this rate varies negatively with things like education and age at marriage. So less economically advanced regions of the world tend to have the highest fertility rates. People tend to get married youngest and have the least education. As people become more affluent and better educated, they tend to marry later as well And this has a profound impact on fertility. Here is a map of fertility about the Earth. Notice that Canada, Europe, Asia, Australia have the lowest fertility rates. Even China, although it has a very dense population, has low fertility rates because of its policy of one child per couple. Modest fertility rates are found in the US and South America and North Africa into India. It might be surprising that the US has a modest fertility rate, considering that we are economically and educationally advanced. Much of this has to do with immigration into the US. However, if we look at the population that is here already, fertility rates also tend to be rather low. The highest fertility rates in the world are found in sub-Saharan Africa, parts of the Middle East, and also in Oceania. One last topic under the heading of human populations is that of demographic stages. There is this phenomenon referred to as the demographic transition, which consists of stages in how it is that populations grow and change over time. The first one of these is referred to as the pre-industrial stage. And in this stage, birth and death rates are high. It's what we would have seen in populations in the Middle Ages or in antiquity. And consequently, population growth is slow. You see these phenomena on the left-hand side of this graph under the heading of stage 1. Now, as we move to stage 2, we are in the industrializing or transitional demographic stage, where we still have high birth rates, but death rates start to drop as technology improves, nutrition improves, and things like that. And so at this stage, populations start to grow. And this is what we saw happening in human populations in the 1700s. As we move from stage 2 to stage 3, now we are on the right-hand part of the graph, and we are now entering the industrialized demographic stage, where birth rates drop, death rates drop, and so population growth increases. The post-industrial demographic stage is what we see farthest to the right on this graph. It is characterized by low birth and death rates and stabilizing populations as birth and death rates reach replacement levels. This is what we see today in places like Europe. So here we have a slide that summarizes some of this with the 4 demographic stages. Once again, the pre-industrial, the industrializing, the industrialized, and the post-industrial demographic stages. Let's consider some of the impacts of human population growth. Not surprisingly, as populations grow, they put an increasingly great strain on natural resources. We do live on a planet which is finite in size with a finite amount of resources, so as more and more people use these resources, they get subdivided further and further. If we think in terms of food, in parts of the world today, there is simply not enough food to go around, and inadequate nutrition tends to lead to weakened immune systems and the appearance of diseases and illnesses illnesses associated with inadequate nutrition, like vitamin deficiencies and things like that. In terms of disease, high-density human populations are much more efficient at transmitting disease organisms than our low-density populations. So for organisms like bacteria and viruses, high human populations are ideal for moving through a population. It is these kinds of high density situations which lead to the development of things like epidemics. If we think in terms of economics, when we have high population growth rates, that can outstrip an economy's ability to provide opportunities for people. This is a kind of phenomenon that we see today in parts of the Middle East, for example, where their growth rates are so high that these countries cannot provide jobs for their citizens fast enough. High human populations also restrict access to even renewable resources, because again we have more and more people subdividing a resource class. Even something like wood, we can grow more wood, but if the rate of population growth outstrips the rate of wood production, then there is less wood per person. And we can think of a number of examples of renewables being subdivided further and further by expanding human populations. One last issue to consider is what happens to everything else that lives on the planet, that live in natural habitats. As more and more land is taken over for human use, there is less and less land available for everything else that lives on the planet. And so, as we've already discussed in our previous topic, rates of endangerment have skyrocketed around the globe for many different kinds of species of plants and animals. All this brings up the issue of sustainable population size. So the question is, what population of humans can our planet actually support sustainably? We obviously can't continue to grow indefinitely because, again, we do have a finite number of resources for humans to use on this planet. So various strategies have been explored as means to attain sustainable population size. Things like family planning, increasing educational levels of populations, which, as we've seen, is associated with reducing population growth rates, providing career opportunities for individuals. When we have greater affluence, then we tend to have smaller population sizes, and individuals begin having children at later ages. All these things contribute to population growth rates being minimized. If we look around the globe, places like China have provided incentives to families to have only one child. They've had the so-called one-child policy for quite a number of years, although that policy is now being reviewed and it could be changed, which for the world as a whole may not be such a good thing, considering that China has the largest population of any country. India has done less well at controlling its burgeoning population. Initially it focused on family planning like China, but that did not work out well for them. But more recently they have worked on decreasing fertility rates by improving educational opportunities for their citizens, which leads again to more economic opportunities. And associated with greater economic opportunity is, again, greater age at which families are begun and smaller family sizes. In Europe, with its high levels of education and affluence, population growth in many countries has equaled approximately zero. In some countries, there has even been negative population growth. From an economic standpoint, this can have some negative consequences for the future economic health of some of these countries. If we don't any longer have an adequate workforce to fuel economic growth, this can be a negative. So in places like Italy now, there are some issues with things like that. However, economists have also been re-examining how it is that we think of such things, asking the question, should our economic models be based on continued population growth and expanding markets? Maybe we need to rethink this in terms of a model which is indefinitely sustainable. And so with that, we complete our topic of populations. And next time we will begin a discussion of environmental pollution, which of course is a direct outgrowth of expanding human populations. And so we will begin with that next time.